Given a current I that extends from one infinity to another, we have to find the direction and magnitude of the magnetic field at point P, which is A away from the current. Using the right-hand rule, we see that the magnetic field at point P is directed out of the board when you sweep your fingers along the direction of the current.
Okay, so the first step in solving this problem is ultimately breaking up the current into two different parts. So what we did is right here we have the horizontal component of the current carrying wire. And so the first step, so actually what we have to do is we're going to have to use the Biot-Savart law, which is ultimately determining the magnetic field of a current carrying wire. So what we have to do first is determine the coordinate system for this section of the wire. And what we did was we put the y-axis right where point P is, and then the horizontal is the horizontal x-axis. So first what we have to do after that is determine a point on the current carrying wire that is ds. So you can put it anywhere on the current. We're going to put it right here. So this right here is going to be ds. The next step is to attach a length r from ds to the point P. So this is going to be r. And we know that the direction of a current carrying wire in respect to ds and r is ds cross r. So what you do is pretty much your thumb is going to be ds. So you point in the direction of the current, and your r is going to be your index finger. So this angle is going to be your alpha angle, and your fingers that are pointing out this way is going to be the magnetic moment. So we know that the direction of this current carrying wire is out of the board. Okay, so, and as I said before, this angle is going to be alpha. And then the next thing to do is obviously determine your variable. So here our variable is going to be x, or whatever letter you want to call it, as long as it's not a or p or I. So you can just call this x right here, and this is obviously going to be r. So to determine what r is, it's ultimately just the Pythagorean theorem. So it's going to be a squared plus x squared square root of both. That's it.
So we're going to use the Biot-Savart law to determine the magnitude of the magnetic field. So in this, the constant mu stays the same over 4 pi, and the current will stay the same. And then for ds, we've determined ds to equal dx according to our picture. So it's going to be dx over r squared, which we have determined to be a squared over plus x squared according to the Pythagorean theorem. So we're going to multiply all that times sine alpha, which is opposite over hypotenuse. So it's going to be a over r, which is the square root of a squared plus x squared. And then, because this is a derivative, we're going to have to take the integral of this. And for our horizontal current, it's going to be from negative infinity to a.
Okay, so I'll be dealing with the vertical portion of the current that we're talking about. So what you want to do first is build a coordinate system like this. And then from there, you want to go and carve out a piece of the current, label it ds. And it's better to put it on the outside rather than the ends because you don't get a really good result at the end of it. So from this, you can then draw a line that'll be your hypotenuse, label that as r, and our a is already drawn there. And then to find the direction of the magnetic field, you want to use the right-hand rule. So what you want to do first is have your thumb as your current, make sure that's pointing upwards. Then your r vector is going to be pointing this way, and your result is going to be that the magnetic field will be pointing outwards. So I'll go ahead and do that. And then also in the Biot-Savart law, you're going to want to find the angle between your r vector and your ds vector. So I'll go ahead and label that as the alpha. And, oh yeah, and also our variable of integration at the end of it is going to be y. So at the end of it, ds is going to be equivalent to dy.
Similarly to the horizontal axis, for this current, we're going to use the Biot-Savart law, which is this right here. And according to this law, the mu naught and 4 pi are constants, so those remain the same. And I also remains the same, but ds becomes our integration variable dy over r squared, which we determined to be a squared plus y squared according to the Pythagorean theorem. And sine of alpha, according to our figure right here, is equivalent to the opposite over the hypotenuse, which is a over r, which is a over the square root of a squared plus y squared. Because this gives us a derivative, we have to take the integral of this, and so our integral goes from, has bounds from a to negative infinity. So to find the total magnetic field, we have to add our two axes because we broke it up in the beginning. So we basically find our total magnetic field's magnitude by adding the magnetic field from the horizontal and the magnetic field from the vertical.